All right, ladies and gentlemen, we've got Skill 7, which is our flipped lesson for this unit. All right, so in class we talked about hamburgers, stoichiometry, and we used the hamburger analogy to kind of see how the amount of our ingredients does affect how much we can ultimately get out as a product at the end of a recipe or at the end of a reaction. And so what we're going to do right now is we're going to talk about something called the mole ratio. And we talked about this ratio also in class, but we didn't exactly put a name on it. And we didn't use it to the fullest extent that you're going to be required to do. So right now, we need to know that when we are dealing with stoichiometry, stoichiometry is going to be the word that for this part of chemistry involves mass and volume relationships in chemical changes. So it's going to be how we know how much stuff we have, how much stuff we produce, if a reaction can occur given what we have put in. There are 4 steps that we are going to follow. We've got them outlined here below. And the first of them should be very familiar to us. You've got to balance a equation. The reaction must be balanced in order to correctly get the ratio between the reactants and the products, meaning we need to have the right coefficients in order to get these things to work. So if you balance incorrectly, everything else you do afterwards is going to be wrong, unfortunately. All right, we're going to find the number of moles given of the substance. Okay, we'll see how we do that. We're going to inspect the balanced equation, and we're going to determine a mole ratio. When we come back and we do this in our problem, you're going to have this written here, but we need to still know that a mole ratio is going to be the moles of the required substance over the moles of the given substance. All right, so it is a ratio like you do in math class. Instead of writing it a 1-to-1 relationship like this, like with the colon, we're going to instead write it as a fraction. Okay, so then we are going to express the moles of the required substance into what unit it needs to be to finish the problem. So whatever it is that it wanted at the start, we've got to make sure that we have that unit when we finish. All right, so let's take a look at an example problem, because all those steps don't mean anything until we actually do them. So the first thing that we've got to do is balance this. So I see that H and O are reacting to form H2O. Nice synthesis reaction in case you were wondering. Okay, and so we're going to balance this. I've got 2 H's and 2 H's. I've got 1 O and 1 O and 1 O. So I'm going to put a 2 here, and then I'm going to put a 1, and I'm going to put a 2. So make sure that I'm all balanced. Now, the question becomes, how many moles of each of these substances do I have? All right, so all I'm going to do is put in my coefficients. These coefficients tell me exactly how many moles of each I have. So I'm going to take the 2 that's in front of the H2. I've got 2 moles of hydrogen. I've got 1 mole of oxygen and 2 moles of H2O at the end. So now, if I want the ratio of those moles, the ratio of O2 to H2, the ratio of O2 to H2, written like that, I'm going to get these numbers. I'm going to get the 1, which was the coefficient, over the 2. It's a 1-to-2 ratio, and I have a 1-to-2 mole ratio written. Okay, now down to the actual nitty-gritty, what we need to do for a question. So I'm going to ask you in the question, if I want to burn 5 moles of O2, how many moles of H2 gas do I need? Meaning, if I know that I have 5 moles of O2 and I want to make water, how much H2 gas do I need to make this go? In other words, I've got 10 hamburgers. How many rolls do I need in order to make a certain number of burgers? Okay, so we're going to follow this. The moles of the unknown, we're going to set equal to our known value times our mole ratio. All right, so here's our setup. You're going to take your given. The given is 5 moles, and I'm going to label that given. Okay, and you are going to go dot line is equal to, and we want to end up in moles of H2. Okay, does this look familiar? Because it should. It's exactly how we do a dimensional analysis. And I'm going to clarify that this is moles of O2 that we start with. Now, what we need to do is use our mole ratio. If I have 5 moles of O2, how many moles of H2 does that really entail? That means I need to use my mole ratio. And that mole ratio is the one that we came up with up here. So, I have moles of O2 and I want to get rid of them. So I want to make sure that I put the O2 down here so that it'll cancel, and I put the H2 up here so that it's left over. Alright, so my O2 has a coefficient of 1, and my H2 has a coefficient of 2 on it. So I have a mole ratio of 2 to 1, which is just the inversion of the one that we came up with up here. So if I figure this guy out, I go 5 times 2, and I do get 10 moles of H2. So in order to make this reaction happen with 5 moles of O2, I need double the amount of H2. I need 10 moles of it. Okay, so let's take a look at example 2. The first thing that we need to do is make sure that we are balancing the reaction. So before I even read the question, I'm going to balance. So I see that my N's are out of whack. I'm going to put a 2 in there, and then I'm going to recount my H's. I've got 3 times 2 is 6, so I need to put a 3 in here, and I'm going to put a 1 in for my N2. Alright, so now I'm balanced. Now let's read. How many moles of ammonia, that's the NH3, are produced when I have 0.6 moles of nitrogen? So my given is 0.6 moles of N. Alright, so I'm going to clarify that for myself because that is what I ultimately want to start with. And I want to end up with moles of NH3. So let's set this up. Start with your given, 0.6 moles of N, dot line is equal to some number of moles of NH3. Alright, so my given is moles of N, so I want to make sure that I can cancel out my N, so put that on the bottom. I want to make sure that I put my NH3 portion of the mole ratio on top. So now it's time for the mole ratio. So we take a look at our balanced equation, and we see that we're dealing with ammonia and we're dealing with nitrogen. So somehow we're going to have a 1 to 2 relationship or a 2 to 1 relationship, it doesn't matter. So the NH3 gets the 2, so we put the 2 on top, or it's 2NH3, and we take the 1 from the N2 and we put it down here. Okay, and now for our answer, we are going to be going 0.6 times 2 is going to give us our number of moles. And if you put that in there, we're going to have 1.2 moles of NH3. Okay? Alright, so I also need you to notice something that's occurring here. We have canceled exactly what we need to cancel. We've canceled the N's, and all that's left is NH3. And every single number in here is still related to the mole. So it doesn't matter whether moles is technically canceled, everything. There's moles of N2 is left and canceled here, but we still got moles technically of NH3. Okay? So let's come on down to the next one. Oops, there we are. And I would like you to give this one a whirl. So first you have to balance it. You need to decide what your given is, and you need to set it up. So pause me right now and see what you get. Okay, so for this question, the first step was to balance it. You get a 4, 3, 2 as your balance. Then we're going to read our question, and we're going to see that we've got how many moles of aluminum. So first we're dealing with aluminum, and our given is 3.7 of Al2O3. So I'm going to underline that those are the two that we're going to be dealing with. Oops, we're in a highlighter still. So we're dealing with aluminum, and we're dealing with these guys. So my given is right there. That's what I'm going to start with. 3.7 moles of Al2O3. So Al2O3 dot line is equal to, and we want to end up with moles of Al. Okay, so now we need our mole ratio. We need our aluminum to our Al2O3. So my Al2O3 goes on the bottom because I want to cancel it out ultimately with this guy right here. And then my aluminum itself is going to go on the top because that's ultimately what I want to end up with. So it'll be a 4 from right here to a 2 from right there. Okay? And so if I do this, I get 3.7 times 4 divided by 2, which will ultimately give me an answer of 7.4 moles of aluminum. I hope that that is also what you got. So follow me onto the back page of your notes. All right, ladies and gentlemen, so you followed me onto the back page, and we are given this question. Given the balanced reaction, we need to see how much water will be completely produced if 5 moles of H2 are completely reacted. And we're dealing with this equation, which is a pretty simple synthesis of water. It is already balanced for you. So you've got the 2 on the H2, the invisible 1 on the O2, and the 2 that we've got right there. So my given, I'm going to label. I've got 5 moles of H2, and I want to know how much water. So I'm going to put a star by my water and a star by my H2 because those are the ones that I'm currently concerned with. So start with our given. 5 moles H2 dot line, and I would end up with moles of H2O, moles of water. So if I want to cancel out my H2, then that's going to tell me it belongs down here, and I want to end up with H2O, so I put it here, and I'm just going to read the coefficients off of my balanced reaction. The coefficients are the mole ratio. Coefficients equal a mole ratio. There will be a question on your test which asks if you know that. The coefficients equal the mole ratio. So the H2 goes here, and the 2 from the H2O goes there. It is a 1-to-1 relationship. 5 times 2 divided by 2 is still 5. But now you have your unit, and you're all good. All right, number 2 is going to deal with the same balanced equation. Our given is still 5 moles of H2, but this time instead of dealing with water, we're dealing with oxygen. So I would like you to take a moment and set this up. Pause me and unpause when you got it. Okay, so what you should do is start with your 5 moles of H2. Dot line is equal to, and you want some number of moles of O2. So the O2 is going to pop in here because you want to end up with that. And the H2 should go on the bottom because you don't want it. You're dealing with O2 and H2. H2 has a 2 coefficient, the O2 has a 1 coefficient. You're in a 1-to-2 relationship. So you are going to get 5 times 1 divided by 2, which I'm just going to write as 5/2. Okay, and if you give me a decimal form of that, that's absolutely fine. Okay, let's come on down to our next question. Number 3 and number 4. So here's how this is going to work. I'm going to do number 3 on here for you. I'm going to ask that you pause, do it yourself, and unpause when you want to see the answer. Number 4 is the question that you are going to do by your lonesome. I am not going to put the question, or the answer rather, on here. You are going to be required to have number 4 completed when I see you in class tomorrow. I will be checking it. So let's look at number 3. I crossed off given the balanced equation because clearly this is not balanced. So the first step that we need to take here is to actually balance that reaction, because if I don't have the coefficients, I can't properly do this. So I'm going to see if everything is balanced. So the first thing that I notice is that I have 4 N's here, but I don't have 4 N's there, so I'm going to plop a 4 in because that makes sense. And now I'm going to see how many O's I have on this side. I've got 6 O's here, and I've got 4 here, so 6 plus 4 gives me 10 on this side. So I need to get 10 over here, so I multiply that by 5. All right, so now I'm balanced. Okay, so let's read your question. We're going to take a look, and we have given to us 12 moles of O2, and we want to know how many moles of NO are produced. All right, so we're going to start with our given, 12 moles of O2, and I'm going to put a box around my O2 and a box around my NO, because those are the only two that I'm concerned with right now. So 12 moles O2, dot line, equal to, and I want to end up in moles of NO. All right, so now put in where I want everything to end up. NO, I need to still have at the end of this, so NO is going to be here, and O2 needs to cancel out with these O2s. So my O2 coefficient is a 5 from right here. My NO coefficient is a 4 from right there. I plug them in. I can cancel. I know that my O2 is going to cancel with my O2. I'm going to be left with moles of NO, which is exactly what I want. So if I multiply this, I've got 12 times 4 divided by 5. So 48 divided by 5 doesn't come out even. You're going to get a decimal, and that decimal should be 9.6 moles of NO. If you don't have your units, you're going to lose points, so please be aware of that. So number 4 is your homework. I will check it tomorrow. Please balance the equation right here, balance it, set up your mole ratio, set up your dimensional analysis, and come in ready to eat s'mores tomorrow. All right, thanks for watching. See you tomorrow, unless there's a snow day.